The 1991 Gulf War inflicted enormous damage on the Kuwaiti oil industry, thrusting tragic images of environmental destruction onto our screens. But out of this devastation came a unique opportunity to observe and assess the impact of major fires on large oil storage tanks. The Home Office Fire Research and Development Group undertook a survey of several Kuwaiti facilities to see what lessons could be learned for the British Fire Service. This program is a brief look at the study made by Divisional Officer Mike Freeman and Robert Bladen, a consultant engineer from Motherwell Bridge Projects, during July 1991. They were able to investigate the full range of oil tank fires and in less than a fortnight collected much valuable information that would normally take years to acquire. Some of the destruction was a direct result of sabotage or attack by hostile forces, and some was caused by friendly fire. There was extensive damage from uncontrolled fires, for in many cases little or no firefighting took place due to the presence of occupying forces. In other incidents, fire spread because of inadequate or damaged equipment and failed water supplies. 4 tank farms were inspected. The North Pier loading area near Mina Shuaiba had 2 tanks which were particularly interesting. The first was a floating roof tank which had partially collapsed. It had foam pourers around the top and a deluge water system around the shell to cool the tank. However, the water supply to the spray system was put out of action by the fire. Had the pipework been buried in the bund and protected where it came out of the ground, it would have been serviceable. The position of the fire monitors directed at the tanks seemed to show that cooling parts of the shell contributed to its collapse. It's possible that the cooled areas became rigid, and coupled with the force of the monitor and the softness of the rest of the shell, the metal sagged inwards. This phenomenon might in certain circumstances be used to advantage. For example, to force down the side of a partly full tank to allow foam to be applied to the fuel surface. However, a distorted shell can make foam application difficult if it covers part of the fuel. The second tank had a fixed roof design and was larger in diameter than the first. No attempts at firefighting had been possible, and the tank had completely collapsed, spilling a large amount of oil into the surrounding bund to within 2 meters of the top. 5 months after the fire, the bund was still full of oil, but it had remained intact. The fire had apparently extinguished itself, but no analysis of the fuel was possible to determine why. The efficiency of the bund prevented the spill fire spreading onto the adjacent main road or to other tanks. The 2 tank bunds were similar in construction, one covered by tarmac and one by oiled sand, equally effective against wind erosion, but the oiled sand may be prone to water erosion. North Tank Farm at Ahmadi is the smaller of 2 tank farms owned by the Kuwait Oil Company. Fires had burned here for 3 or 4 days before the occupation forces allowed firefighters onto the site. But as the water tanks had been blown up, their efforts were severely limited. Tank 54, a floating roof design, had about 7.7 meters of crude oil in it at the time of the fire. The surrounding bund was compacted sand and gatch covered with oiled sand. This tank was involved in a violent boil-over. Firefighters who were there at the time, when questioned, gave a detailed account of the sequence of events. They had very little warning. The noise of the fire increased and the smoke lightened. They moved quickly away, but a foam tanker they'd been using was destroyed by the fire as the oil fell into the bunded area. A burning wave of oil formed, which swept over the bund and poured down into the pump house, starting a fire which caused the electrically powered fire pumps to fail. Despite the intensity of this wave, the integrity of the bund was maintained. As a result of this incident, it's recommended that standby systems for the fire pumps should be provided as a backup, a small generator or a diesel-driven pump. Tank 55 had a rim seal fire, which was still burning at the time of the investigation. Firefighters were having problems in getting the foam to penetrate under the weather shield and onto the fire. The layout of tanks 51 to 55 demonstrated the inadequacy of placing several tanks within a single bund, separated only by low-level dividing earthworks. These token walls couldn't contain the burning oil from one tank, which spread freely within the bund, igniting the other tanks. One constant problem was the adverse effect of high winds on foam pourers, particularly those around the circumference of the curb angle on some tanks. The foam was blown away before it could run down the shell. Modifications to the outlet nozzles had been tried, but these weren't successful as they discharged straight into the tanks and would have interfered with the tank roof when full. One solution would be to enlarge the back plate behind the pourers, allowing the foam to run easily down the container shell. The Kuwait Oil Company's South Tank Farm sustained some friendly fire, but suffered mainly from systematic sabotage by the occupying forces, including the complete destruction of two 1.5 million gallon water tanks. The shell manhole was blown off. The sudden outflow of water caused a vacuum rip-zip effect, splitting the tank from top to bottom. Here again, the bunds at South Tank Farm had functioned effectively. Tanks 34 and 35, both with floating roofs, shared a common bund. These tanks had been destroyed by demolition charges to the inlet and outlet nozzles. No firefighting took place, and yet the resulting spill fire was contained by the bund. The bunds are made from local sand and gatch, easy to open up when major maintenance work on the tanks needed to be done. However, they do require a lot of space. Some tanks used the stairs to the roof as a support for the fixed fire protection equipment. Unfortunately, this arrangement proved useless as the stairs were damaged by the heat from the fire. The fourth tank farm was at Doha power station. The heavy fuel, crude and gas oil stored here was for the use of the power station. Only 2 of the heavy fuel tanks escaped. The rest were destroyed by enemy action or the uncontrolled spread of the resulting fires. The destruction of Tank B provided some useful lessons on the design of fire protection systems. This large fixed roof tank with a capacity of 45,000 cubic meters was surrounded by a single reinforced concrete bund. Built in 1981 to AP 1650, it had fixed fire protection consisting of a water spray system, foam inlets into the top of the tank, and foam pourers into the bund. The foam system pipework was just above ground level outside the bund. At the time of the incident, the tank was about 3/4 full, holding 35,000 cubic meters. The fire started after the tank was hit by an Iraqi missile. The upper plates became heated and collapsed inwards under their own weight. The station staff had been removed by the Iraqis, so it's possible that the protection systems weren't operated. The foam supply pipework outside the bund was put out of action by a spill fire from another tank. Fixed fire protection systems should themselves be protected. 2 nearby tanks had similar protection systems. In these cases, the water supply was automatically activated when the explosions occurred, preventing the Tank B fire setting them alight. 3 refineries operated by the Kuwait National Petroleum Company were also inspected. The main damage at Mina Ahmadi was caused by explosive charges in the control room and at the loading jetty. Damage to the storage tanks wasn't extensive. A few had suffered bullet and shrapnel holes. The firefighters dealt with these leaks by plugging the holes with wooden bungs hammered hard into place, a very efficient short-term solution. The Mina Shuaiba tanks were severely damaged, several being completely destroyed. An interesting point here was the success of hydraulic platforms in dealing with the early stages of a tank fire. This was fully demonstrated by fires in 2 identical tanks with the same result: partial roof venting. One fire was accessible to a hydraulic platform, and was extinguished with AFFF foam in 30 minutes. The other, which was inaccessible to hydraulic platforms, took 2 hours to put out, using ground monitors and the same foam. Access for hydraulic platforms at tank farms should be seriously considered. A major fire in a large fixed roof tank clearly showed the efficiency of water spray systems. 2 adjacent tanks fitted with sprays didn't ignite despite the wind direction changing several times. The refinery at Mina Abdallah was extensively damaged, including the destruction of all central control. Fortunately, most process units could be operated locally. It's worth considering this localized control capability for all installations. The main interest here was the success of one tank design feature, the frangible weld at the top of fixed roof tanks. This cone-roofed tank was full to its capacity of 12,810 cubic meters. The fuel ignited and caused the internal pressure to exceed the design pressure. The roof blew off, landing 25 to 30 meters away, but the walls remained intact. The surface fire was extinguished with FP70 foam via a Simon snorkel in 4 to 5 hours. Visits were made to 3 gathering centres. These had experienced varying degrees of damage, but common to all was the consistently effective performance of the earthwork bunds. In no case had the spill fires breached the bunds. Ideally, all tanks should have their own separate bund. Several important conclusions can be drawn from the Kuwaiti experience. Fixed water and foam systems should be provided to suit the design and size of each tank. The most effective method of cooling a burning tank is a permanent water spray system around the circumference of each shell. Rim seal fires proved to be more numerous than major tank fires and burned for longer than expected. Given the multiplicity of roof designs, further investigation into methods of dealing with rim seal fires should be made. Earthwork bunds were highly effective, and this was proved beyond all doubt, but consideration needs to be given to their height in relation to tank pipework. Any tank outlets should be well below the top of the bund. Concrete bunds presented some problems. Expansion joints easily burnt out, allowing some oil to pass through, with the possibility that it would spread the fire beyond the bund. Where pipework passed through the bund, some sleeving was deficient, allowing oil to escape. In some cases, fixed firefighting equipment was placed inside the bund or on top of it, where it and the operators were exposed to the danger of spill fires and boilovers. It would be safer to position this equipment outside the bund. Although the events in Kuwait are unlikely to be repeated in the United Kingdom, there are still many useful lessons to be learned. Older tanks close to urban areas are closer together than in the Gulf and cannot be tackled effectively with conventional equipment, so adequate fixed fire protection systems are essential. Modifications to incorporate these systems could be made during routine maintenance. It is vital that firefighters, plant operators, contractors and owners pool their individual experiences and work together in the design and building of oil tank farms.